All right, I put a star by here because this is also something you need to know for the exam. I don't know that we necessarily did that much with it, but it might show up. You should be familiar with the Pythagorean theorem with a right triangle. So important to remember that. Did you remember the Pythagorean theorem?
Yes.
So then you just add these together and take the square root. Gentlemen, can you turn your desk this way, please? For now. Thank you. All right. Okay, so down here. You have to remember for this section, because it's using angle bisectors of triangles, so you have to remember how to do an angle bisector. How many people remember? Yeah? Okay. I can show you real quick. What do you think the first thing is? Use a compass. Right on. To do what? So this is what I do. So I take my compass and I just make an arc somewhere between both of the rays. If I might shorten this a little bit just because you don't have to though. Maybe I'll use the same distance that I had on there. It doesn't really matter. So once I make my arc, then I'm going to put my point on the intersection here. And I'm just going to make an arc like this. Now what do you think? On the other side, on the other point of intersection, make an arc. And then what do you think? And you just do this. And you have the intersection. See it? Not bad, huh? All right, what I want you to do now, there's the angle bisector right there, is I want you to do it for all three of these angles right here. And they're going to meet at some point in the middle. They should, if you did it right. All three angle bisectors. So this is called the in-center when you're doing angle bisectors. Okay, I'm going to just remind you of some terminology. Reminder that the distance in geometry, the distance from a point to a line. So let me just, you don't have to draw this picture, but I'm just going to draw a line and I'm draw a point. Now, in geometry, you have to, we consider the distance of that point to the line, the length of the, does anybody know? Let's say, could we draw a line here? Would that be the distance to the line, do you think?
No.
Or maybe here? Or do you think it's this? Which is the what? Perpendicular bisector. So just as a reminder, the distance from a point to a line is considered the length of the perpendicular bisector. Perpendicular segment, let's say, perpendicular segment or bisector from the point to the line. I mean, it's tempting to say this distance or this distance, kind of, you think that might, but we always consider the perpendicular segment, okay? Here, the in-center is equidistant from all sides. So, if you consider the in-center here, this point, and you were to draw or figure out the perpendicular segment from that point to each side. If you just kind of would to figure it out, like with drawing it or whatever, it would be the same length. That's what that's saying. So this and this and this is all congruent. Sort of makes sense? Okay, turn it over. It's not too much longer. All right, some more theorems here. You don't necessarily need to remember the numbers, you just have to remember the ideas. If a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So right here in this picture, this point is on the bisector. It's equidistant. Converse of the angle bisector. If a point is in the interior of an angle and is equidistant from the sides of the angle, so here's a point on the interior, and it's equidistant, then it lies on the bisector. So I could actually draw a line right here based on this picture. Because it's on this perpendicular bisector to that line and it's on this perpendicular bisector to this line, therefore this is congruent to this and it's also the angle bisector. Concurrency of angle bisectors of a triangle. The angle bisectors of a triangle intersect at a point that is equidistant from the side of the triangles, which is what we just talked about here. We just talked about that theorem. Okay? All right. For what value of x does P lie on the bisector of angle A? So I need to find out what value of x is going to make these two congruent. So I'm going to set them equal to each other. And then just do the algebra. Subtract 1x, and x equals 7. All right, easy enough. In the diagram, G is the in-center of triangle RST. Remember, in-center is the point of concurrency, and it also tells me what about this picture? If it's the in-center, then what do I know about these perpendicular segments here? They're congruent. Okay, find GW. All right, what do you think I can do here? Take a look at that picture. What is one triangle that might be helpful for me to find GW? What do you think, Courtney?
Or triangle GWT.
GWT? Close. We're going to need that, but we will need that, but we need to work with another triangle first. Yes. What do you think? How come you chose that one? Because it's two sides already. See? 12 and 13. And it's a what kind of triangle? Right triangle. So I can find this side by using what? Pythagorean theorem. So look at the picture. Yep, look at the picture always, okay? So I'm going to use triangle GTW, or GTU, excuse me. That's not a good marker. If I do a squared plus b squared equals c squared, c is always which part of the right triangle? Yeah, c has to be the hypotenuse, which is opposite the right angle. A and b, it doesn't matter, the legs. So I'm just going to make a my unknown. You could have made b your unknown too, it doesn't matter. A squared plus 144 equals 169. Subtract 144 from both sides. And a is equal to plus or minus 5, but would we use the negative? No, because it's a side length of a triangle, so it doesn't make sense to the problem. So it's just 5. So I'm going to put 5 right there. If GU is equal to 5, then I know GW is what? Equal to 5. How come? They are congruent or equidistant from, I don't know how I want to say that, from the in-center. Let's say it that way. Equidistant means what? Equal distance, equal length, however you want to look at it. Cool? Okay, that is it.